So we're going to finish up with section 2.4 today. In particular, we're going to talk about transformations. So we're going to start with 7 really basic graphs here. The shape and the picture, the graph of which you should have committed to memory. So these 7 basic graphs start out with a line, namely the line y equals x. So that's the line of slope 1 that passes straight through the origin. The second graph that we're going to look at is y equals x squared. This has a U shape. It's actually called a parabola, and we'll discuss these at greater length a little bit later on in the semester. The third graph looks like that parabola flipped on its side and then cut in half. It's the graph of y equals the square root of x, and it's sort of the top half of a U turned on its side. The fourth graph is y equals x cubed. So that looks a bit like an S that goes vertically instead of horizontally. So it kind of goes like that. It flattens out at the origin and then comes back up and starts increasing again. The next graph is y equals the cube root of x, which again looks like y equals x cubed flipped on its side. So it looks like an actual S now. It goes perfectly straight up just for an instant and then starts to flatten back out again. The next graph is y equals the absolute value of x. This looks a lot like a V, where the tip of that V just barely touches the origin and then bounces back off. And finally, y equals 1 over x. This is sometimes called the reciprocal function. Essentially, the graph looks like you were taking the first and the third quadrants and sort of rounding them off. So, these 7 graphs, you should know what these things look like cold. Now, that being said, of course, you have a graphing calculator with you. You'll be able to use it on the exam, but I think it's worth committing to memory. So what we're going to do with these 7 basic graphs is we're going to transform them. We're going to take them and we're going to move them around somehow. So in what follows, b here is just some positive number. It's a positive constant. F of x is going to be a function that represents one of those 7 basic graphs. Now, strictly speaking, it doesn't have to be one of the 7 basic graphs, but for us, for the most part, that's what it's going to be. There's 6 different transformations that we're going to talk about here, all of which are what are called rigid transformations. There's no stretching or shrinking going on here. You just grab the entire graph and sort of move it around somehow, or maybe flip it vertically or horizontally. So the first transformation, we add this constant outside of the function. So you'll notice here that f of x plus b, that plus b occurs outside of those parentheses. The way that's going to translate when we see an example is it happens outside the main operation, so to speak, like a square or a cube or a square root or a cube root, one of the operations in those 7 basic graphs. So what this does is it takes the graph and it shifts it up b units. In a similar way, f of x minus b shifts the graph down b units. Now, f of quantity x plus b looks a little bit funny, and it looks pretty similar to the first transformation here, but it's not. In fact, that plus b is moved inside of those parentheses, and the way that we're going to see this in the examples that we're going to see in a minute is the addition happens inside of the parentheses with the main operation, either the squaring or the cubing or the square root, etc. And what that does is it shifts things horizontally. You expect, oh, it's that plus b, it's going to shift things in the positive direction. Unfortunately, it doesn't. Happens exactly the opposite of what you would expect. In fact, it shifts to the left by b units. Next up, f of quantity x minus b shifts to the right b units. Again, exactly opposite of what you would expect. Next up, we're going to multiply by a negative. If we do that outside of the main operation, it takes the graph and flips it vertically. So if you imagine grabbing a hold of the x-axis and twisting it like this, that's what happens to the graph. In a similar way, if we multiply by a negative inside of the parentheses, it flips horizontally. So imagine grabbing the y-axis and flipping it like this as if it were a picket sign. It goes like that. So what we're going to do now is take a look at an example. It's very difficult to get a feeling for what's going on there unless we actually take a look at some specific functions. So we want to graph the following transformations of the basic 7 functions that we looked at before. So in part 1, g of x is x squared minus 2. In part 2, g of x is x minus 2 quantity squared. Notice where that subtraction happens there. And in part 3, g of x is negative the square root of x minus 2. First, we're going to take a look at the first part of this example, which was g of x equals x squared minus 2. Now, you'll notice that the basic function to which this corresponds is x squared. So this is going to look like a parabola. But that minus 2 occurs outside of that main operation. And what I mean by that is that squaring, that x squared. The subtraction occurs outside of that squaring. So what that's going to do is take the original basic graph, which was y equals x squared, which you'll see drawn here, and it's going to shift it down 2 units. So what I do is make 2 tick marks on the y-axis here, and the graph that I'm after is the green one. It's the red graph, which is y equals x squared, one of those basic 7 graphs, shifted down 2 units. And that's this resulting green graph, y equals x squared minus 2. Now, at this point, you want to pause the video and give part 2 of this example a shot. What you're going to do is graph g of x equals quantity x minus 2 quantity squared. So go ahead and pause, come back when you've given it a shot, and we'll go through it together. Alright, so at this point, you've attempted this problem on your own. Now, you'll notice that the difference between this part of this example and the last part of the example is the subtraction now occurs inside of that main operation, which in this case is squaring. What that's going to do is shift horizontally. And in this case, because we're subtracting 2, we shift to the right 2 units. Notice that's contrary to what you would expect here. You expect it to go left, it doesn't, it goes right. The key difference here is that subtraction happens before the squaring occurs. That is, it happens inside the parentheses before the main operation takes place. So the original function in this case is y equals x squared. Again, it's a parabola, and again, it sort of touches the origin and bounces back off. But this time, we're going to shift that graph to the right 2 units, resulting in the green graph that we wanted to graph here. Now, again, go ahead and pause the video. Try to graph the third part of this example on your own, which is minus the square root of x minus 2. Come on back when you've given it a shot and we'll go through it together. So at this point, you've tried to graph this all by yourself. So now we'll go through it together. So notice that there's 2 things going on here. First of all, there's subtraction that's occurring inside of that main operation. And the main operation here is that square root. That's one of those 7 basic operations that we talked about before. Now that subtraction inside is going to shift things horizontally. And like we said before, subtraction inside of that main operation does the opposite of what you would expect. So we're going to take the original square root of x and we're going to shift it to the right by 2 units. Now the negative on the outside here is going to flip vertically. Notice that negative occurs outside of the main operation, so it's going to affect the vertical direction. It's going to flip things vertically. So what I'm going to do here is draw the original basic graph, y equals the square root of x. Notice this is one of the 7 that we started off with. Then what I'm going to do is graph the result of shifting it 2 units to the right. So what I've graphed here in blue is just y equals the square root of x minus 2. Notice the conspicuous absence of a negative sign here. It's just the square root of x minus 2. And then finally what I'm going to do is throw that negative on. That's going to take that blue graph and flip it across the x-axis. And what you're going to end up with is the resulting green graph, which is y equals negative the square root of x minus 2. That's the only graph that we actually want to graph here. The other 2 were just sort of for demonstration of what's going on. So if you were to answer this question, that's all you would graph here, is just that resulting green graph. So do keep that in mind. So that's about it. So that about does it for section 2.4. You should be able to finish this section's homework at this point. Feel free to bring any questions that you have to the next class period and we can get them taken care of. Good luck.